So hello everybody, welcome back to my channel. Today we'll be doing AC systems. That is, first in one video I'll be doing single phase and the next one I'll be doing three phase. So let's quickly start without wasting time and try to cover it in the shortest time possible. Okay, AC single phase. Don't think too much, just simple waveform. Okay, total time T 0 pi 2 pi. This is a simple waveform which I'm drawing. I'll also put in terms. This is the peak, that is Im. This is instantaneous speed T, and then this is becomes omega T. This is basically a single phase waveform diagram. Now I'll explain all the terms. How a single phase AC generated when the coil is rotated between the magnets. It generates an EMF. The EMF is alternating in nature, sent to the load. That simply you can remember. It's not that important. The main things I'm explaining right now. Okay. This is a simple waveform, as I told you. It can be 0 pi by 2 pi or 0 pi 2 pi. It works. Okay. This is much you understood the diagram. T equals to 1 by f. I'll explain now. Okay. So first, what is the cycle? One positive and one negative half cycle form a cycle. Next, what is the time period? The time required to complete one cycle. The time required by signal to complete one cycle is known as time period. Time period is given in seconds. T equals to 1 by f. Okay. Frequency is the number of cycles per second. That is given in hertz. Next is amplitude, and f is 1 by t, that is given in hertz. Okay. Next, amplitude, the maximum value of the wave, of the signal of the waveform. That much you can say, maximum value. Okay. Instantaneous time, the time at a particular instant. Okay, or particular time at a particular instant or particular time. You get the instantaneous time. That is what is given as t. Instantaneous value is the value at a particular instant of time. The value of the waveform or signal at a particular instant of time or at a particular time. Okay. Now instantaneous equation. These are all basic, which I think we can write till now whatever I discussed. P equals to Vm sin omega t, instantaneous equation, or I equals to Im, small letters. Okay, my bad. Im sin omega t. Also plus omega t plus or minus 5 also can come. That is the phase difference. These two are not termed with phase difference, but yeah, you can assign omega t plus or minus 5. So you can write. This becomes the phase difference, where Vm and Im are the peak values of the waveform. Okay, and omega value is 2 pi. This much everyone knows. So if this is 2 pi f, I can write this as V equals to Vm sin 2 pi ft. I'm just making it practice so that while solving questions you understand. Done. This much is only basic, nothing much to worry. This much only. I'm trying to make it as short and crisp as possible. Now simple questions I'm going to ask for numericals, which are also asked by the way. Omega t. This is current I'm giving here 0 pi 2 pi. This ampere I'm giving it as 20 A, and time I'm giving it as 1 by 100 second. First they ask what is the peak current. Peak current only they will ask. They will not give you symbol in brackets. What is the peak current? If they ask, as you see you have to say 20 ampere. Next, what is the periodic time period? As you see you have to say 1 by 100 second. Frequency 100 hertz. Angular frequency. Now frequency is 100 hertz. We got how? By 1 by t. Now angular frequency is omega. That also you should know. Angular frequency is omega. That you should know. Omega is 2 pi f. That becomes 200 pi. And one more thing, always when you're doing this module 2 calculations, right, always your calculation should be in radians mode. So you go to calc settings, angle unit, and keep it in radians mode always. Otherwise you get absolutely random answers. So 200 into pi. So I'm getting 628.3185 radians per second. Units of angular frequency is radians per second. If you remember, radians per second. Then there was instantaneous value of I. That instantaneous value is basically I at t equals to 3 millisecond. So I equals to Im sin omega t. That makes it 20 sin omega value. We have got it as 6. I'll take it as 200 pi for now. 200 pi into 3 into 10 power minus 3. So 20 into sine of 200 into pi into 3 into 10 power minus 3. So I am getting the answer as 19.0211 ampere. Done. Next one, simple question similar to this. An alternating current of frequency 60 Hz has a maximum value of 12 ampere. Write equation of instantaneous value. That's the first part. I equals to Im sine omega t. So 12 sine omega is 2 pi f. So 2 pi into 60 t. That becomes 12 sine 120 pi t. That's the instantaneous equation. Find the value of current after 1 by 360 seconds. So next, I equals to 12 sine 120 pi 1 by 360 right over here. That becomes sine 12 into sine of 120 into pi by 360. So I am getting the answer as 10.3923 ampere. Time taken to reach 9.6 ampere. So now suppose graph is here like this. I'm just trying to make you understand. Okay, this is the 12 ampere. 9.6 will be somewhere over here, say, and this one more 9.6 over here. Yeah, because 0 to 12, then 12 to 0 should come, right? 0 to 12, 12 to 0. 9.6 will come over here. So which one you should find? The first time they have told. For the first time, this one they have to find. So I equals to Im sine omega t. Now instantaneous value equation they have given. This is the 9.6. This is what the one which they have given. We know this is 12. Sine. This one we know 120 pi. We have to find the time. Correct. We have to find the time taken to reach this. So first I'm going to do 9.6 by 12, which is 0.8 sine 120 pi t. Now I'm going to take sine inverse. So 0.9272 equals to 120 pi t. 0.9272 by 120 into pi we can do. So I am getting the answer. Let me just check first. Yes, 0.002459. This was the answer I am getting. Sorry, seconds. How did I do this? After writing this, do sine inverse. If you do sine inverse over here, you will get sine will go. So do sine inverse over this side. Okay. When you do sine inverse over this side, you will get this. And on this side, sine will go. Then you will be left with. Did you understood? Okay. Next, some terms are there. Average value, RMS value, peak factor, form factor. First let form factor, then let peak factor. Average value is nothing but the arithmetical average of all the values of an alternating waveform over one cycle. The arithmetic average, just like how you do normal, what is an average? Same thing. The arithmetical average of all the values of an alternating waveform in one cycle is called as average time. The formula you have to remember, that is 2Im by pi. Writing for 1, current I'm writing. Same for voltage, same for EMF. 2Vm by pi, 2Em by pi. Same thing. But this remains same. So 2Im by pi. What is it? The arithmetical average of all the values of an alternating waveform in one cycle. What is the RMS value? This is a little bit tricky, okay. RMS value of an alternating current is given by the steady current or the DC current, which when flowing through a given circuit for a given period of time produces the same amount of heat produced by the alternating current, which when flowing through the same circuit to the same amount of time. What does it say? RMS value of an alternating current. RMS value of an alternating current is given by the steady current, which when flowing through a given circuit for a given amount of time produces the same amount of heat which is produced which same amount of heat produced by the alternating current which when flowing through the same current which when flowing through the same circuit to the same amount of time. Okay, it's confusing, so I'll tell you. RMS value of alternating current is given by the DC current which when flowing through the same circuit for a given circuit. First, if for a given circuit, the RMS value of an alternating current is given by the DC current which when flowing through the given circuit for a given amount of time produces the same heat which is when produced by the same amount of heat produced by the alternating current which when flowing through the same circuit at the same amount of time. Understood? RMS value of the alternating current is given by the steady current, the DC current, which when flowing through the given circuit at a given amount of time, circuit and time. RMS value of an alternating current is given by the DC current, which when flowing through the given circuit at given amount of time produces the same heat as to that produced by the alternating current when flowing through the same circuit at the same amount of time. Simple only. Now this is given by Im by root 2. Okay, Im by root. Now form factor, P factor is there. Form factor, you have to remember, form factor, here RMS is at the top. Okay, form factor, here RMS is at the top. RMS value by average value. It is defined as the ratio of the RMS value to the average value of an alternating quantity, you can tell. Okay, RMS value by average value. So formula you can only derive from this. RMS value is what I just told you, Im by root 2. Average value is 2 Im by pi. This becomes Im by root 2 into root 2 by 2 into Im. This is 2 Im by pi. My bad. So what does it become? Im cancel. So pi divided by root 2 into 2. You will get approximately 1.11. This is almost constant value. Okay. Next, because it is not depending on Im, right? So it is a constant value. Peak factor, here what is on top is maximum value. Maximum value by RMS value. When you hear peak, you have to remember maximum value. Remember form, you have to remember RMS value. So maximum value is given by 2 Im, sorry, it's average value. Maximum value is just Im. Im divided by Im by root 2. 1 divided by 1 into root 2. So root 2 value is basically 1.414. Okay. Did you understand what I'm saying? This also is constant because again it's also not depending on the Im value. So what did I say first when I told average value? It is the arithmetical average of all the values of an alternating waveform in one cycle. 2 Im by pi. Next, RMS value. RMS value of an alternating waveform is given by the DC current which when flowing through a given circuit at a given amount of time produces the same heat as that produced by the alternating current when flowing through the same circuit at the same amount of time. It is given by Im by root 2. Next is form factor. And I say form, remember RMS. So RMS top. So RMS value by the average value. Correct? So that value you can see because average value we know 2 Im by pi. This one value we know Im by root 2, so that we can solve. Next is peak factor. Maximum value by the RMS value. In peak factor average will not come. Peak factor maximum value by the RMS value. At least if you know 1.11, 1.4, you can, if you forget, you can try to get it. So Im by you can get it. Okay. Now again few questions I'll tell. The equation of an alternating current is given by I equals to 42.42 sin 628 ampere Calculate the maximum value. As we see only, we can tell the maximum value is 42.42 ampere. Frequency. Now, this, if you see, it is in the form sine of coordinate t. It's given in sine omega t format. Omega equals to 2 pi f. 628 equals to 2 pi f. F equals to 628 by 2 pi. That's going to be 628 by 2. That's going to be 99.9493 frequency. So it's going to be in hertz. Next is time period. We have got frequency. So time period is 1 by f equals 1 by t. So t is 1 by f. So 1 by 99.9493. I'm getting 0.01 second. Next is average value. Average value is what? 2 Im by pi. So 2 into 42.42 by pi. 2 into 42.42 divided by pi. That is going to be 27.0054. Approximately, I'm getting this answer only. Okay. Next, RMS value. RMS value is given by Im by root 2. 42.42 by root 2. 42.42 divided by root 2. I'm getting the answer as 29.99 ampere. Then form factor. I'll just write it somewhere here itself. Form factor. That is going to be, form factor means, remember, RMS. RMS by the average value. That is going to be, RMS value did we find out? Yes, 29.99 by 27.005. 29.99 divided by 27.005. That is giving me basically 1.11. I told it's a constant value. Remember, for RMS we call this itself. Next, I have access to my form factor. We know the answer should be 1.414. But I will get to check. Form factor is what? Maximum value by the RMS value. RMS value is 29.99 ampere. So 42.42 by 29.99. Yes, we are getting 1.414. Okay. Those have no units as such, just constant. Okay. So this much. Next question, let's do quickly. I equals to 40 sine 314t. Now there was frequency. Similarly, omega equals to 2 pi f. This is omega. I equals to Im sine omega t. So this is f. So f equals to omega by 2 pi. That is equals to 314 by 2 pi. So 314 divided by 2 into pi. The answer is 49.97 f hertz. Next, they have asked the average value. Average value is given by 2 Im by pi. That is 2 into 40 by pi. So 80 divided by pi. The answer I am getting is 25.464 ampere. Because there was current only, average value of current. Because current equation. Next, form factor. Form factor is what? RMS value by the average value. Here average will come in form factor. In peak factor it is maximum value by the RMS value. RMS will come in both, but that will remember. Sometimes a chance to forget. So RMS value have you got? No. So Im by root 2 divided by average value we have got 25.464. Or you can do 2 Im by pi, cancel or you can do. So 40 divided by root 2. This should be divided by 25.464. So I'm getting the answer is 1.11, which is correct for form factor. Next is peak factor. I know we're supposed to get 1.414, but let's check this way. I have to always do this and show them that this is how. Otherwise, everybody knows the constant value. So peak factor value is maximum value by the RMS value. So 40 by RMS value again. Okay, I'll just do it separately. 40 by root 2. That is 28.284. So 40 divided by 28.284. That is going to be 1.414. Done. Okay, from here the main part starts, the harder part of that. Okay, so till now what we did was basics, introduction. And now what we're going to do is, there are 6 cases. Okay, pure resistor, pure inductor, pure capacitor, then you have RL, RC and RLC. For pure R, pure L, pure C, you have to write following things: circuit diagram, current equation, derivation. Okay, derivation. Then you have to write the phasor diagram. Then you have to write the power equation. And then you have to write the waveform. So what in order we write? Circuit diagram, current equation, phasor diagram, the waveform and power equation. For these 3 things, circuit diagram, little bit extra here, and 2 definitions, all that is included here only. Current circuit diagram, current equation, phasor diagram, power, waveform. For these 3, when I'm coming to RL, RC, and there's some tricks also. Okay, here for all of these, all the waveforms are equal. The waveform length is equal. I'll tell you when I'm explaining also. And here there is no phi and all is not there. But when it comes to this RL, RLC and all, their waveforms are unequal. I'll tell you more about it. And here 5 plus previous one, 5 plus 5 minus 5, all that will be there here for these. And here what not you have to write, RLC is slightly exceptional. Okay, for these 2 I'm telling right now. You have to write the circuit diagram. Current equation derivation is not required, just the equation you can state. Then phasor diagram, voltage triangle, impedance triangle. In impedance triangle only cos phi value also you can mention. Power equation, waveform. These things you have to write. Circuit diagram, then you can just state the current equation. Phasor diagram, voltage triangle, impedance triangle. When voltage triangle only I am including the derivation of that also. So power equation, waveform. Okay, for RLC, I doubt RLC will come because it's a very huge question, so I don't understand how they could fill it for 7 marks or whatever, but I'm just telling, we want to prepare it anyway. But it's not that deep. Okay, just here for this, according to my notes I'm saying circuit diagram, phasor diagram, neither current equation is given, voltage equation is not given, because if here you're going to measure like XL greater than XC, or is XL greater than SC, or is XL equal to SC. Those are the 3 cases which is going to come here. So current equation, phasor diagram according to that, and then you have voltage triangle, impedance triangle. There is no power equation, only waveform after that. This is what I have written. Okay, circuit diagram, phasor diagram, current equation, voltage equation, impedance triangle and waveform. Okay, so let's begin now. It's going to be a slightly longer video. The first cases are pure R. Okay, first one, pure R, is the easiest, so very quickly we can understand. When AC signal is applied to pure R, okay. Now first is the circuit diagram. Resistor, am I alternating signal video? That's enough. I R, V equals to Vm sin omega t. That's it. Now that's it. For R, I am just saying it's very easy. So we have to always find the current equation. V equals I into R. I equals to V by R. So Vm sin omega t by R. This is going to give Im sin omega t. I equals Im sin omega t. then V equals to Vm sine omega t. So is there any phase difference? There's no phase difference between current and voltage equation. Both are in same phase. One current equation part is done, circuit diagram part is done. Next we'll go to the phase diagram. Phase diagram 0. Listen, for this is different, for others it is different. Here 0, pi, 2 pi will work. For this I have to include pi by 2 also. And also you have to remember, okay, 2 pi, this is omega t and this is current equation. So remember how to draw. I'm going to draw in different colors for you to understand. This is voltage, okay, don't forget this is voltage. Current is going to follow the same path because there's zero phase difference but a little bit lesser intensity. It's not equal, but yeah, guys can manage it. Now both are V and I both are up, so power is going to be like this. I have to actually first derive the power, but I started drawing this first. So both are negative, so negative going to be positive. For this one, I'm going to draw power equation first, then I'm going to draw this. This is power. This is voltage, not current. First we're drawing voltage. This is current. Did you understand? Power part you can share it in exams. This you can share and show. Okay. This is the diagram. P average equals to Vi. All that you can show if you want, but better to show actually. Like this one line you can draw, and you can show P average equals V. I'll show you how V into I came. So power equation V into I, that's going to be Vm sine omega t into Im sine omega t. So Vm Im sine square omega t. Now this formula, as soon as you see sine, you have to remember this formula. Cos 2 theta equals to 1 minus 2 sine square theta. So 2 sine square theta equals 1 minus cos 2 theta. Sine square theta is 1 minus cos 2 theta by 2. That one you have to write over here. P equals to Vm Im 1 minus cos 2 theta by 2. So Vm Im by 2 minus Vm Im cos 2 theta by 2. In others it is different, okay, don't get confused. In others it is different. They were trying to use sin 2 theta formula. You have to remember, if sin square omega t is a, why are you going to make it sin 2 theta format? You want to make it into this format. You have to consciously remember certain things, okay. Now wherever cos 2 omega, it won't become cos 2 omega t, it will become, okay. Now, okay, what it is, cos 2 omega t will become. Now this part will become the pulsating part, the fluctuation part. This will become the constant part. So P equals to Vm Im by 2. That is equals to, I can write it as Vm Im by root 2 into root 2. That is going to become Vrms into Irms. That is basically I'm going to write as P equals to V into I, where V and I are RMS values. That's why the average value we can write as P average Vm by 2 Im by 2, we can write it as P average value. So basically you can write it as P average Vi. There again at the top you can write it like this over here. So we do the circuit diagram, current equation, phasor diagram. Okay, instead of phasor diagram I drew the, okay, my bad, sorry guys, instead of the phasor diagram I drew the waveform. So phasor diagram, V always put with the longer one and I also in the same direction. So V I, that's a phasor diagram, both are in same phase. That's the waveform. This is the power equation, instantaneous power equation. So circuit diagram, current equation, phasor diagram, power equation and waveform. Done. It was very easy, right? Now let's go to pure inductor. Pure inductor. First is the circuit diagram. LE. So what can we write here first? We write some definition, that is when alternating current is flowing through this, a back EMF is, when alternating current is flowing through a pure inductor, a back EMF is induced because of the inductance of the coil. When alternating current is flowing through the coil, a back EMF is induced because of the inductance of the coil. E equals to minus L di by dt. The direction of the back EMF is opposite the direction of the voltage. V equals to minus E. So V equals to L di by dt. First it right when alternating current is flowing through the pure inductor circuit and induced EMF when pure inductive coil, you can see back EMF is induced. The when alternating current is flowing through a pure inductor or a pure inductive coil, a back EMF is induced because of the inductance of the coil. The direction of the back EMF is opposite to the direction of the supply voltage. This much is done. Now we got V equals to L di by dt. Now we have to start deriving the current equation. So di equals to V dt by L. That V I am going to expand Vm sin omega t by L dt. Now integrate on both sides. I equals, now integration of sin omega t, how are you going to remember? If you remember, then go to sin differentiation is cos, cos differentiation is minus sin, so sin differentiation is minus cos. So Vm by L minus cos omega t by minus omega, minus cos omega t only. Okay, only omega will come. Yeah, only omega will come because it's not minus omega here, right? So minus cos omega t by omega will come. Why is minus cos omega t coming? Because integration of, see, differentiation of cos is minus sin, so integration of sin should be minus cos. So minus cos omega t by only the coefficient is positive, so minus cos omega t by omega will come. This much you understood. Now always we want for pure inductive and pure capacitive in the form of pi by 2 type. So what we are going to do is, this is a tricky part. Okay, listen. Cos theta equals to, for this pure inductive, I am doing pure inductive, right? So that minus I am going to use. That I am going to use minus concept. Listen. Sine of pi by 2 minus theta. So minus cos theta will be minus of sine pi by 2 minus theta. That can be written as minus cos theta equals sine of theta minus pi by 2. Did you understand? So minus cos of omega t is what we got, right? So minus cos of omega t is given as sine of omega t minus pi by 2. Do you understand? We wanted that phase difference to be of minus pi by 2. Do you understand why we do this? For pure inductive and pure capacitive current equation, power equation, will be using cos only. So I equals to Vm by L omega minus cos omega t also I am writing. That's also a correct equation. But we are going to write it in terms of pi by 2 as well. Vm by L omega equals, what did I say? Sine of omega t minus pi by 2. Sine of omega t minus pi by 2. So this one L omega equals to XL. So I equals to Vm by XL sine omega t. This is basically V equals to I equals to V by R format. So I equals to Im sine omega t, where Vm by XL is basically the Im. Do you understand what I'm telling? Do you understand? Im sine omega, sorry, omega t minus pi by 2. I forgot to write. Did you understand? That is the current equation. Now after current equation, what should we do? We should find the phasor diagram. So I equals to Im sin omega t minus pi by 2. V equals to Vm sin omega t. So current lags behind voltage by 90 degrees. So this is the voltage and this is going to be the current. It is lagging. This much again you understood. Current is lagging. After current is always lags behind the voltage by 90 degree. This is the phasor diagram. Now there is no impedance triangle, voltage triangle, all that is not there in this. Okay, I told you in the top what knowledge is there for what, right? There is no impedance triangle, voltage triangle for this. For a second I got confused. So what are we going to draw now next? Power equation. Power equals to V into I. So Vm sin omega t into minus Im cos omega t. Do you understand? I'm not going to use sine terms over here. I don't want complex sine of pi by 2 omega t minus pi by 2. I want to make it complex. So Vm minus Vm Im sin omega t cos omega t. Now I'm going to look what I'm going to do. I'm going to multiply and divide by 2 Vm Im by 2 into 2 sin omega t cos omega t. So 2 sin theta cos theta is given as sin 2 theta. So minus Vm Im by 2 sin 2 omega t. So now this entire term, because of all of this, is going to become pulsating. So the average power over a average value of a sine waveform or complete waveform over complete cycle is going to become 0. So pure inductor consumes 0 power. Now let's look it into the waveform. For this I need 0, pi, 2 pi, but here I want pi by 2, here I want 3 pi by 2, here I want 5 pi by, because it's going to be 2, okay, yeah, correct. Now look, current equation. Now current is lagging. If current is lagging, it is going to start from here. Remember that. And don't start from here. No, where I'm starting from, start from there. I'm not saying my curve is exactly correct, but I'm just telling. It should have been more that side, but because of the end of the page, I'm just trying it. This is the current equation. Now power equation, you have to draw in paths. From here to here, positive, negative. So what is going to be the power? Like this. Next, both are positive. Like this. Okay. Just give me a second. Yeah. Next, positive, negative, it's going to be negative. Next, again, same, negative, so it's going to be positive. That's it. And one thing you have to note is that this is gone a little too big. The waveforms is a bit of adjust. One thing, all of these waveforms are of same size. It might not look like that in now, but they all are of same size. Okay. So this is power equation, this is voltage, and this is current. All of them should be of the same size. That's what I'm trying to say. In these, so P average is 0. As you can see, 2 over here, they will cancel and become 0. That's one more way to understand. So we drew the circuit diagram, we derive the current equation, then phasor diagram, power equation, waveform. 5 things done. Next, let's go to pure capacitor. So once you have tried this, consider a capacitor of C farads is connected to the AC supply, and the capacitor has charge. The current charges the capacitor. The instantaneous charge on the plate. Just write pure capacitor of C farads. AC voltage. It is connected to AC supply, or it is supplied by AC voltage. Current charges the capacitor, and that instantaneous charge is given by Q equals to CV, and the rate of flow of charge is basically current, that is given by I equals to dQ by dt. I'll write small I. So I equals to d by dt of CV. So I equals to, this much you understood, I equals to d by dt of C into V sine omega t. V equals to Vm sine omega t. My bad. Okay, Vm sine omega t. So I equals to C Vm d by dt of sine omega t. So I equals to C Vm cos omega t into omega. It's differentiation. So I equals to Vm C omega cos omega t. Now Xc is basically 1 by omega c. XL is L omega. that is okay, but xc is 1 by omega c. xl is in the same line, xl is equals to L omega, so we could replace it easily. Here you see xl was L omega, we could replace it easily, but here xc is 1 by omega c, so omega c is here, so omega c is going to be 1 by xc, so I equals to Vm by xc cos omega t. I told you what in pure inductor and pure capacitor we want it in the form of pi by 2. So cos theta, here I am going to do it as plus, there I use it as minus, right? What did I tell that time? Cos theta equals to sin pi by 2 minus theta I told. Here I am going to say I equals to, cos theta equals to sin of pi by 2 plus theta. So cos of omega t will be sin of pi by 2 plus omega t. Again it's omega t plus pi also. I equals to Vm by xc sin of omega t plus pi by 2. This is the current equation. So I equals to Im by xc, basically x this is not, this is xc, okay. So v equals to so I equals to Im sin omega t plus pi by 2. So v equals to Vm sin omega t. Here current and voltage are not in same phase. Current is leading the voltage by 90 degrees. So phasor diagram, how am I going to draw? This is the voltage, this is the current. Current is leading the voltage by 90 degrees. Next power equation, let's see power equation. P equals to V into I. Vm sin omega t into I am going to try the cos format only. Im cos omega t plus, here no plus, my bad, I was getting confused with LCR. So here is going to be Vm Im same by 2 sin omega t cos omega t. That is going to be Vm Im by 2 sin 2 omega t. This is going to enter become a pulsating term, and the average power over the cycle is going to be 0. Now let's go to the waveform. One second, yeah, let's go to the waveform. Okay, now I have to extend this side also. Now it's current is leading. See, one more thing I have to remember is that current is leading. Here it's easy to remember, okay, everything is going according to what we plan, but in RL and LC it is a little bit opposite. Current equation and phasor will tell one thing, but impedance and voltage will tell something else. It's a little confusing there. I'll come to that as well. This is going to be minus 5, this is going to be 0, this is going to be, okay, there's no 5 here, oh my god, I'm getting confused. Okay, minus pi by 2, pi, 3 pi by 2, 2 pi. Okay, this is correct. Minus pi by 2, 3 pi by 2 and 2 pi. Current equation I'm going to draw now. Current is leading, so it's starting from the top itself, but it's the negative direction. There it was, it's starting from bottom but positive. That must also deep drawn by heart now. 5 pi by 2 I have not written. Why, what is happening, I don't know. It should not come this big also by the way. Okay, so power, let's draw from here to here, then some mistake is there, why is it so small, then here to here, all that of the same size, which might not look like that now, but it is. This is power, this is voltage, this is current. Okay, this much you understood. Okay, this was the power equation. Here also P average is 0. Now RL, LC and RLC. Let's go to that as well. I'll just give me just few seconds. I'll continue. It's quite long. I'll just take few seconds break. Or I'll just continue the next video because I don't want to make it too long as well. I'll do one thing. I'll just continue the next video. Okay, and it's becoming too long. That's fine. Otherwise, if I finished, there's just few more topics. I'll do the next video. I'll do RL, RL, RC, RLC, and even the power 3 powers that also I finish. So thank you so much for watching. See you in the next one.